Alright, let's try to discuss the strategy for calculating a projection vector. It's really not too difficult, but if you try to do too much at once here, you're going to get totally confused. So focus in on the various components of calculating a projection vector. I've got two cases here, and I'm going to consider projecting vector u onto v in both cases. So let's start over here. If this angle between u and v is obtuse, then the projection vector of u onto v, well, I'd have to extend v, my axis onto which I'm projecting, drop a 90 degree from the tip of u down, and my projection vector in this case looks like this. So my projection vector here looks like this. It points in the opposite direction of vector v. Okay? Over here, well, I don't have to extend my v-axis because u sits over the top of it. This angle here is acute. When that happens, I can simply drop down to my axis perpendicular, and my projection vector sits right here, points in the same direction as vector v. Alright, so the strategy for this, actually calculating this projection vector, there are two parts to it. So the projection vector, let's make that thinner. The projection vector of u onto v equals, basically it's going to be some length times some vector. Okay? More specifically, the length here is literally the length of the projection vector, so you'd have to be able to calculate that. A vector has much more than a length. It has a length and a direction. So literally, I just want to know the length of this vector, not the actual vector yet. So to make this projection vector equal an actual vector, I have to take this length times some other vector. Well, the vector part of this focuses in on how do I get the direction of my projection vector the correct way. And the way to do that is to use v. V is our axis that we're projecting. So our projection vector is going to point basically in the same direction as v or in the opposite direction of v. Okay? In fact, it might even be easier to think of this in terms of a unit vector, right? If you look at the unit vector that points in the same direction as v, it might look something like this. And you know how to easily calculate a unit vector in the same direction as v. So the unit vector in the direction of v is called v hat. We put a hat over unit vectors. And over here, v hat would be in the same spot, just like this. So the vector here that we multiply by is going to be the unit vector in the correct direction. So in this case, where the angle is acute, I want my unit vector, I want it to be pointing in the same direction as v. So in this case, my unit vector is actually v hat. But if the angle between the two vectors is obtuse, my unit vector's v hat is pointing the wrong way. I need it to point the other way. So what I really need, let's change colors here. What I really need is the opposite of v hat, -1 times v hat. So the unit vector is going to be v hat. If you want your projection to point in the same direction as v, it's going to be negative v hat, -1 times v hat, if your unit vector points in the opposite direction. Okay? And then finally, to calculate the length of the projection vector, you would focus in on this right triangle, and you would actually need the angle in this right triangle to find that. So this length depends on the angle in the right triangle. Okay? So to calculate that angle, over here, the angle in the right triangle is literally the angle between u and v. Over here, the angle in the right triangle is 180 minus the angle between u and v. So you'd find the angle between u and v, subtract it from 180.